All right, y'all, we are going to be taking a look at section 5.5. 5.5 focuses on graphing linear equations and inequalities. So we're going to be able to basically graph these within two variables, so x and y, and then also solve applications. So one of the first things that we want to take a look at is the idea of actually being able to put points on the graph. So when we're taking a look at a blank graph, we have the two axes, and you can see here that they are labeled for you. So we have the x-axis and the y-axis. So our coordinates are always written x, comma y. So you always move to the left or right first, and then move up or down. So let's say that we wanted to graph the point 1, 3. So that tells us that our x value is 1 and our y value is 3. So we go to the right one, which would be this guy right here, but we're not done yet. Put the pin down, see if it'll let me try it again. Oh, okay, great. So we start by going to the right one, and I'll just draw an arrow, and then we want to go up 1, 2, 3. So this would be where our actual point is. A lot of times points are labeled with a capital letter. So we could say that this was point D, and then we had a crack on the axes, we can label it as such. If you had a coordinate, let's say that was point P, okay, so -3, let's say 2. So because it's a negative value for that x, we're going to go to the left, -3. So we'll go 1, 2, 3 over, because we're going to -3 on the x-axis, and then we want to go up 2, 1, 2, and so this would be where point P is. So when we're taking a look also with axes and graphing these coordinates, one of the other things we want to keep in mind is that these axes and coordinates and all this, they also have the idea of something that's a quadrant. Okay, and the way that we count it is counterclockwise. So we start with quadrant 1, then quadrant 2, quadrant 3, and quadrant 4. So what you can see when we label these quadrants also is that in the first quadrant, everything is positive. So you have positive x and positive y. When we move over to the second quadrant, now we're in the second quadrant, our x values are going to be negatives, our y values are going to stay positive. Okay, as we keep moving around and we get to the third quadrant, both of those values are going to be negatives. And then lastly, when we end up in the fourth quadrant, our x values are going to stay positive, but our y values will be negative. So that's also just something good like to have as a rule of thumb as far as which quadrant you're going to end up in. Well, if you just look at the x and y values that you're given, that should inform you. So if you would like to pause the video, take a second and try plotting these. I'm going to take a second and we're going to talk about which quadrant they end up in. And so if we're looking at the first point that we're given, -5, +4. Okay, so our x value is negative, y value is positive. That's going to end up in quadrant 2. And you can go back to the previous slide, just refer which quadrant that is. Then we take a look at the second point it gives us, -3, -4. So our x and y values are negative. That's going to land us in the third quadrant. Taking a look at number 3, we have 2, -3. It's going to put us in the fourth quadrant. And then lastly, we have this point here for number 4, that's 0, -1. So this is actually going to land us in a quadrant, because if we were to go to graph this, I'm going to draw a really crude graph here. But if we were plotting that point, 0 for our x value means we're not going to the left or right. -1, we're just going down 1. So it ends up on an axis. Whenever you have something that graphs, an axis, excuse me. So whenever you have something that graphs onto an axis, okay, it does not land in a quadrant. It's just on the axis. All right, so talking about graphing linear equations in two variables. You're going to see this represented in a couple different ways. The most common way is the standard form right here that it gives us, which is the ax plus by equals c. Okay, so this is the standard form. What you're probably used to seeing is the point slope form, which looks like y equals mx plus b. So that's where it gives you the slope as m and then the y-intercept as b. And so whenever you're taking a look at problems like that, it just understand that these can represent the same exact line. They're just written in a different way. Linear equations have infinitely many solutions, and there's always a point that you can graph provided that it has a solution. All right, so you can see here it says gasoline costs $3.53 per gallon. You put 10 gallons of gasoline in your car and pay $35.30. Your friend puts 15 gallons of gasoline in their car and pays $52.95. Your neighbor needs 5 gallons of gasoline. How much will they pay? So this is an example of a linear expression because the gallons of gas are going to cost the same as they go up. Let's say it's $3.53 per gallon. So your friend, even though they're buying 15 gallons of gasoline, is still paying at the same rate, the same constant that you are. You just had to get less gas. So if we need to figure out for your neighbor, we can multiply our 5 gallons times that 353. Go to Desmos. So they're going to pay $17.65 for this. All right. So the other idea that we have is this idea of graphing linear inequalities. When we graph linear inequalities, very similar to what we looked at a little bit earlier in this chapter, we're going to end up basically having to shade one direction or the other. So when we looked at these earlier in this unit, we were just drawing our arrow one way or the other. But now we're actually taking a look at what if it's actually above or below a line. So it says determine whether the ordered pair 0, 0 is a solution to the inequality y is greater than x plus 4. So checking a solution, what we're going to do is we're going to plug in our values for x and y and see if we make a true statement. So this would be 0 is greater than 0 plus 4. Okay, so just substituting our x and y values from the coordinate pair, seeing if this makes a true statement. So 0 is greater than 4. And then looking to see, is that a true statement? No, that's not. 0 is not greater than 4. So it's not true, so it is not a solution. And a lot of times what we'll call this, as we're checking a point, we call it a test point to see if it satisfies the original inequality or not. So what you can see here is basically the explanation of those two ideas. We saw this before, again, if it's bounded or not, or if it's a strict inequality or not. So you can see that when you have these strict inequalities, right here, the boundary line is what we're given. It is not included in the solution, and it is dashed. So when it's a strict inequality, when we go to graph it, we're going to graph a dashed line. Then you can see for the next one that it's a non-strict inequality. It has the equals to, okay? It is included in the solution, and when we go to graph that, we graph a solid line. All right, so this one says the boundary line shown in this graph is y equals 2x minus 1, right? The inequality shown by the graph. So we see that it's been graphed for us, okay? And the way that they were able to graph it is they took a look at this expression right here. Okay, so y equals 2x minus 1. What they started with was this negative 1 right here, and they graphed that as the y-intercept. You can see that there on the graph. And then they used the slope to move from point to point. So the slope in this case was 2. So we would go up 2 over 1 to get to our next point. Up 2 over 1. Okay, so we can see that that's how they created this boundary line, but it's asking us to figure out what the inequality represents. Okay, so looking at this, what we want to do is we want to pick a test point from, let's say, we want to take a test point from the side that has the shading on it, okay? And we want to just see if which way the inequality would have to go to satisfy this expression. So that point is -4, 0. We see that it is in the solution set, okay? So what we're doing is we're going to plug in, so we know that 0 equals 2 times -4 minus 1. I'm going to take out that equals, because what we're trying to do is figure out the relationship between these two. So this is a space right now that's going to be filled in with a less than or a greater than. And I know that it has to be a strict inequality because I can see that that line is dashed. Okay, so we have 0, and then again, we're leaving like a blank space. 2 times -4 is -8, minus 1. 0 again, leaving a blank, -9. And we're filling in what the relationship between those two is, okay? So what we're saying is 0 greater than -9? Is 0 less than -9? 0 is greater than -9, okay? And so we filled in that space. So now what we're going to do is just fill that back in to the original problem. So y is greater than 2x minus 1. If you also wanted to go the other route of checking a point that is not in the solution, right, you could test 7, 0. That would also let you know that you need to have which type of inequality. All right, that is it for 5.5. We'll start review soon, and I will talk to you later.